Okay, so I've just already signed into Pangeo and gone ahead and entered that git clone command. I posted it in the Slack general channel. It's the same one, well, similar to the ones we've been using throughout last week, so that you can go ahead and clone the data access repository, which has the tutorial that we're going to work through this morning. And if I could just get a quick maybe green light from people once they've been able to access that tutorial or download and clone that repo. We're going to be going into the notebooks directory, and we're going to be using tutorial 2 data access. So first, I'm just going to be giving you a little bit of background information. So if you can just let us know once you've been able to get into that tutorial. Feel free to ask for help on the Slack channel. And in the meantime, I'll start going over some of the background. You're welcome, as with the other tutorials, to either watch in the Zoom window, or you can also go through it yourself. And that's up to you. So let's see, put that out of the way. How is this for font size? Okay,
It's looking pretty good.
Seeing a few nods. Awesome, thank you. So as Anthony said, icepyx really came about at the end of last year's Hackweek. I was working on my project team, but also talking with other project teams, and we really saw this need for coming together as a community and sharing a lot of our common resources, so that as scientists we could really focus on getting towards the thing that we're most interested in, which is the actual science, and spend less time on the data access, the data manipulation side. But as scientists, we're also having to become data scientists just because of the incredible volumes of data that are being produced by ICESat-2 and a lot of other resources as well. And so that's really how the motivation for icepyx came about. And I really want to encourage everyone here, their students, their advisors, to get involved, talk to us. If you're not comfortable with developing software but want to learn, let us know that too. This is completely new for me. I'm not trained as a software developer like you guys, many of you. I'm trained as a glaciologist. But I think that this sort of open science, open source way of doing science is how we're going to be able to make the most of these incredibly rich data set sources that we have. So just to review, Amy spent a few minutes on Friday going over what a lot of the different data access options are. And as we said, there are multiple options, there are multiple correct options. She introduced open altimetry, which is a really great way to visually explore the data. But what icepyx is trying to do is trying to really unite the entire research process. So instead of having to switch between all of these different resources in order to get from data discovery to data access to final publication quality figure, we can do it all in this one single Python framework. And icepyx is really trying to put a big wrapper around all of the different tools that you've been learning about and will keep learning about this week, and a whole bunch of others that we don't even have time to cover, with the goal that we can all move towards sharing our research, sharing our hard work in a way that's very effective for other people being able to build on it instead of having to recreate it from the ground up. And so what I'll be covering today is specifically programmatic access from the NSIDC data center using icepyx. And this work is actually based on, and the underlying code was initially based on the tutorial that Amy presented last year on data access from the NSIDC using Python. So under the hood, it's doing the exact same things that she taught last year, but what we've tried to do is make it a little bit more user-friendly on the surface. And so if you're going to be following along, we can go ahead and just run this first cell in the notebook, which is just importing the libraries. And what I'll be covering throughout this tutorial is what are the key steps that are needed to actually access data. So if we all just take a step back and think about what our typical workflow might look like, we're defining some sort of spatial and or temporal parameters. It might be the entire world, it might be the entire data set that is available, but we're still defining some sort of parameters of where and when we want data for. So that'll be the first step that we'll go through. Then what we want to do is similar to if we were working in open altimetry, we would sort of query the data that's available and say, okay, I've given you these bounds on my search, what's actually available? And in this case, we'll be doing that programmatically through the NSIDC through something called the Common Metadata Repository. Then in order to actually access that data, we need to, again, as if we were doing it through Earth data, we need to log in. And this is important for NSIDC being able to, see who's using the data and how much, and to develop their services appropriately. Then we're going to go over briefly, because there are a lot of them, but we're going to go over some of the awesome subsetting and customization options that are available for us from the NSIDC. So what tools have they built that allow us to get a data set that is really tailored to our needs? Then we'll go through the process of actually placing a data order. Some of you might be familiar with this through the Earth data portal for other data sets, where you have to say, I would like this data set, and you actually have to order it before you're able to download it. And then once we've completed that ordering process, we can go ahead and actually download our data. So we're going to go through this tutorial. We're going to go through these steps in detail, but the way icepyx has been built, it also allows us to have all of this control over our download and what we're downloading, but it's also meant to be really easy. So in the grand scheme of things, you can do this entire process in 3 lines of code if you don't have a lot of subsetting things that you're interested in getting. And so now I'm going to pass things off to Amy, and she's going to talk us through the search parameters that we can submit to NSIDC.
Okay, thanks, Jessica. Thanks for that intro. So yeah, we're going to start this sort of step 1 is really sort of the core behind icepyx, which is creating this data object. And once you have this data object, the idea here is you are sort of defining this this object that has all of the information that you are basically providing to your data request. So all of the parameters that are specific to the data you're interested in. So I'll kind of walk through just these, what's listed here in text, these sort of what's required as an input, and then also some additional parameters that you can specify that just sort of provide a little bit more sort of custom tailoring to again, the data that you're interested in. And just sort of a note, in general with sort of how the API and all our ordering is structured, it's very, it's kind of, single data set specific. So you really sort of need to be in that frame of mind that, you kind of want to have one particular data set of interest. If you are interested in multiple data sets, you can certainly kind of create multiple data objects and then create sort of these multiple requests, but sort of keep that in mind. So those 3 required inputs, the first is your short name. So this is kind of bit of a just sort of terminology that's a part of, at the NSIDC and a part of that larger NASA Earth data system that I talked about on Friday. These are kind of synonymous with dataset IDs. You should all be pretty comfortable with these at this point. So these are things like basically all the data sets we've been talking about in that sort of code ID, which is ATL03, ATL06, 07, etc. We have a link, which you can take a look at with sort of all the data sets listed for ICESat-2 on NSIDC's page. Again, synonymous with ID, we have longer names for each data set that provide the level and more detail. But again, this is what we're talking about with 03, 06, 10, ATL 07, 10, etc. So that's what short name is. Spatial extent. So this is basically a region of interest that you are available, or that you're interested in accessing. So there are multiple ways that you could input this information. And we're going to walk through kind of the simplest case, which is just sort of a bounding box with, sort of your upper left, upper right, bottom left, bottom right, etc. So we'll walk through that, but there are additional ways that you can input your spatial extent of interest. So you can also do this with polygon, basically like polygon coordinate pairs. So if you want something a little more detailed than just a simple bounding box. And you can also input an area of interest as a geospatial file. So we have that listed, currently shapefile, KML, GeoPackage are supported, but just note that some of these are untested, and we can certainly provide more guidance. There's a lot of additional documentation on, for icepyx itself on how to do this. So if you are interested in kind of these more, I guess, advanced ways to search for data, we could certainly provide more guidance on that. And then finally, the other required parameter is your date range. So this is pretty simple. icepyx kind of made this a little easier if you just sort of interested in a date range by day. You can do that, just sort of a year, month, date string separated by comma. Then moving into these sort of more finer controlled parameters, you can also input a start time and an end time. And then your version, you can also kind of specify that. So, and I will say that this is also synonymous. I know that other people on the science team and in the project office have been talking about sort of the newer release. So most of the level 3A and below products have versioned up to version 3. So again, that's sort of synonymous with the ICESat-2 releases. So we're up to version 3 right now in most cases. And if no version is specified, icepyx knows to just give you the most recent version. But if you know that you, for one reason or another, want a previous version, you can specify that as well. So just a note on a couple of notes here for sort of some gotchas and just sort of things to keep in mind. For spatial extent, again, this is sort of what's your region of interest. And just something sort of to note, and I know we looked at this kind of briefly on Friday in open altimetry. This is basically just showing, what tracks are available, over that area. This is sort of based on the metadata that's provided for each granule or file. But note that that's in some cases kind of an estimate. So you might find that although the coverage kind of states that it's over a certain area, once you actually look at the data itself, and again, you can do this through open altimetry, you may find that the data don't actually extend exactly, over that bounds. You may have missing data, if there's cloud cover or other sort of issues. And Jessica, I don't know if you'd be able to move to the Programmatic Access Guide tab that I sent you earlier. And if you scroll down, there's a figure, and this is through the NSIDC Programmatic Access Guide. There's a link on the tutorial that I walked through on Friday with this. I know it's a little small to see, but basically this kind of gives you an idea of when we're talking about, first sort of searching for an area. Thanks, Jessica, for zooming in there. We talk about kind of zooming in on an area of interest. So in this case, this is actually, we're looking at SMAP data right now, not ICESat-2. But let's say our area of interest is over Colorado. That's always an easy example since it's just a box. So we can first sort of specify a search for that area. So that bottom left is kind of saying, okay, over Colorado, here's all the granules on the data that's returned. And some of them kind of extend outside of that box. And again, there might be like missing data within that box, just sort of depending on what the data, the data are available. But then you can also specify, the next step kind of over on the bottom right is if you actually want the data sort of cropped to that area, that's sort of what we're talking about by subsetting. So Jessica's going to go into this in a little more detail later on, but sort of this is our first step when we're defining that area, is really just saying, you know, what's that bounding box? And then through the granule metadata, we're sort of getting back all the data that might overlap that area. So anyway, that just might be sort of a helpful figure to kind of understand sort of this initial sort of search process, and then we'll kind of get into the actual subsetting or sort of cropping or extracting the data later on. And then we'll sort of show this version warning in just a second, but you should get a warning if you specify a version that's not the most recent. So yeah, if we go ahead and run that first cell, this Pine Island Glacier cell, we're now setting up the our data object. So we're specifying the short name. We're going to be working with ATL06 in this example, and a spatial extent over Pine Island Glacier, the same area we looked at on Friday. And then we kind of just picking an arbitrary date range just to kind of get a small number of files returned for this demo. The next cell that Jessica ran is now setting up our object. So we're specifying this as region A. So this is going to be our object, and we're inputting the short name, the spatial extent, the date range, and then we can also provide those finer details. So in this case, that's start time, end time, and in this case, we're specifying version 1, just to show that in this case, you are that is an older version. Again, version 3 is the most recent data, so you'll kind of get this warning back. So that's just an example to show that warning. Jessica's showing right there. And then you can print all of those sort of parameters. So let's repopulate that object now. And we're just going to give it the short name, spatial extent, and date range. We didn't get that warning because, again, icepyx knows to just pick the most recent version, which is version 3. So if we print those parameters again, you know, the data set, date, start time, end time, the version and spatial extent, we now have, just by default, our start and end time is going to be, you know, the beginning of the day and the end of the day. We have our most recent 003 version, and again, that bounding box that we already specified over Pine Island Glacier. So the next line, we can now, with our object, our data object, we can visualize the spatial extent, which is really nice. So it's pretty small in this figure, but Jessica's circling Pine Island Glacier. So this is just giving you obviously a global map, but that spatial area is highlighted in kind of an orange color that you can see kind of down there. So that's, again, just a nice way to see that, you know, sort of to visually kind of, you know, confirm that your area is correct. So moving down, this is commented out, but you can also, you don't necessarily need to sort of create your spatial extent and short name and create those objects. You can enter that all in just directly into your object, just to kind of skip a step if you want to do that as well. We can get some more information about our data set. So there's some built-in methods that now that we have sort of our data object created, we can now get some information. So in particular, this is one example where we can print the latest version. So that's that first line that shows, again, 003 is the latest. And then this data set summary info method allows us to get some just basic information about that data set. So again, this is coming from the metadata, from the common metadata repository. So we see that full title of the data set, the start time of the entire data set. So that started in October 14th of 2018. That was when the first data were produced for public consumption, and then just a quick summary. So that's sort of a nice way just to get some basic information. If that doesn't give you all the information you're looking for, you kind of want more details about the data set, this data set all info method gives you everything that we have, again, through that metadata repository. So it's going to give you a lot of details on data access URLs, and many other things. I'm trying to think of all the different information, orbit parameters, yeah, data access, even some basic information on tools and services that we're starting to provide, whether there are subsetting services available. Jessica's going to go into more detail on, etc. So that hopefully kind of gives you just sort of the basics. So that's step one of creating our object, querying some information about that data set, and now we can actually move into more details about querying the number of files within the metadata repository. So I'll hand it back over to Jessica.
Thanks, Amy. So as Amy showed us with that really great figure before, there's multiple steps for actually getting the data. And the first one is that we're just trying to actually check in with the NSIDC and look at that metadata and say what's available for the parameters that we've specified. So right now we've specified those parameters locally, and we've found some information, gotten some metadata information for NSIDC from NSIDC. And now we'd like to say, okay, we have this really high level data set information. Can you tell me a little bit more about what specific files or granules are available? So most of you are probably very familiar with the concept of granules, whether or not you actually are used to using the word. Granules are basically data files that have specific bounds. Usually they're spatial bounds. You can think about it as, I mean, most of the remote sensing imagery that many of us are familiar working with comes in some kind of granule or swath. And basically it's just a way to parse the data into a bunch of smaller files. And so for ICESat-2 data, that's called granules. And we can think of those as individual snapshots, and the way that they'll come back to us is as individual files that cover specific geographic areas during specific times. So the first step that we need to do is actually to query the data and see which granules are available for the things that we're interested in. And a lot of this stuff happens behind the scenes automatically, but we wanted to walk you through it because this is where you really start being able to say, okay, I want to make these really subtle changes. I don't want to use exactly all of the defaults that NSIDC would accept. If you want more control, this is where that really can start happening. So the first thing that's going to happen behind the scenes, but you can also do manually, is that we're actually just going to create these query parameters that are going to be fed to the CMR, the Common Metadata Repository, in order to search for what granules are available for the version of the data set during the times and for the spatial area that we're interested in. So once that's been created, we can, for our region, see what granules are available using the avail granules method. And what that's going to do is it's just going to go out and it's going to say, NSIDC, what granules are available, and it's going to calculate some statistics about it. And this is a really great first step because it means that you can check to make sure you're not actually accidentally trying to download a terabyte of data when you're not expecting to. So what this is telling us is that for the particular parameters that we've given it today, there are 5 granules available. And then we can see the average size of those, and the total size is 111 megabytes. So relatively small, easy to download data set. Another thing that we can do is by feeding it this particular flag, IDs equals true, this is the same command as above, we can see what the actual IDs of those granules are, which is obviously going to be helpful because they're a very standard naming scheme for the granules across all of the data sets. And if you would like a lot of information similar to the all information flag above, you can look at specifically what granules are available. And this information is all stored within the icepyx data object. And again, is available for access for you, but is also available to the library to start searching for these granules on your behalf, and will be used for things like submitting your order. And so if we go ahead and run that, what we can see is for each individual granule that is available, we have all of this detailed information. What are the times and dates? Where exactly is this particular granule in space? What are some of those orbit parameters? What coordinate system is it in? How big is this individual granule? What area does it cover? And then again, some of those pieces of data access information. As you can see from the scroll bar, this is a very long output, which is why we provide the simple functions to get just the list of the IDs that you might use, and then to also find out some summary information that can tell you whether or not you think you want to download this set of data. So now that we've queried our data, in order to go ahead to the next step, we need to actually log into Earth data in order to be authenticated as a user of Earth data. And so hopefully you all were able to register with Earth data successfully ahead of time. And that has to be done through the website. You can't do that directly through icepyx. If you're running this tutorial along with me, you'll have to enter your user ID and your email address in this top box. I'm going to run the bottom box. If you run the bottom box, you're not going to be able to log in because you don't have the password for this particular account. So just as I said, if you're following along and want to log in, fill out your information in this top box. And then when you run the cell, it's going to prompt you for a password. So you can go ahead and enter your password. It won't show up, and then you press enter return. And we can see it's still taking a moment, and we've been able to successfully log in. If you have entered your password wrong, it's going to tell you that you were unable to log in, and it will give you an opportunity to retype both first your Earth data user ID and then your password. This will happen a series of times. And after about 4 or 5 times, if you haven't managed to enter the correct username and password, you'll have to run the function again. On occasion, this does take a moment or an error message will be returned. Sometimes the best thing to do is to restart your kernel and or your browser, restart your Pangeo instance and try again. I've had several times where it just takes a few minutes. And that's all there is to that. Okay, so now we're logged in, and this step is really important because what you can't see is that behind the scenes, there's a bunch of information that is now attached to your region A icepyx object. And that information is going to be fed to NSIDC anytime you're trying to access information that is behind their login. So if you don't complete this step, most of the functions that we're showing from here on out will return some sort of error warning that says, did you log in or have you started a valid Earth data session? And that's just a reminder to make sure that you've actually completed this step. So quickly summarize where we are. We've submitted our basic information. We found out what granules are available, and we're now thinking about, okay, this is our list of granules. This works for us. This is the information we want to download. And we're thinking about placing that data order. So we mentioned earlier, and Amy showed this really great figure of the difference between filtering, which is that step we just did to actually get information about what granules are available, and subsetting. And so what we're going to talk about now is some of the additional parameters that are available to you, both for subsetting and for specifying things about how your order is actually placed and downloaded. So in our case, we have a relatively small number of granules because we didn't want to overwhelm the system with all 50 or 60 of you trying to order data at the same time. But as you can imagine, if you have a much longer time range or a larger spatial extent, you might have more than 5 granules that you're trying to download. And so some of these parameters are what allow you to configure how your order will be placed and processed and then downloaded from the NSIDC. And so I'll just go through these quickly. The first one is page size. And this is just how many granules are we going to request in each order. So when you say, go ahead and order my data, it's going to submit your list of granules as a series of separate orders, and you can put X number of granules in each order. And this just changes how fast it is for the NSIDC system to process your order. And then you can start downloading it. Your page number, this is set up automatically behind the scenes. And this parameter is just allowing the software to walk through and make sure that all of your orders are placed and subset. The request mode, there are two request modes. One is asynchronous and one is synchronous. You want to use the synchronous one, which is also known as streaming, with a lot of caution. That requires a direct continuous connection between you and NSIDC, which means that if that connection is interrupted, your order and or your download are interrupted, and the only way to go back to them is would be to restart things. In contrast, if you submit something in asynchronous mode, what this allows you to do is it allows any order that you place to be queued by the NSIDC, and so it will get to it as soon as it can. And so this is, I think, the better and preferred option. Amy can jump in if I'm wrong on that, but it allows for the NSIDC to say, okay, I have all of these orders coming in and I'm going to process all of them. If you try to place a synchronous order and a whole bunch of other people are also placing orders, you might have a little bit more trouble getting your order. And so this is set automatically to asynchronous. I don't know of very many situations where you would want to change it, but this is where you would want to change it. Again, some other options that I'm not going to go through in detail. You can look at the NSIDC resources if you want some more information about these other parameters, but agent and whether or not you include metadata, these are set up for you by default and should provide you with all the information you need once you've downloaded. And then in the notes here, if you are placing a larger order, we have some more information about how many granules you're allowed to place in a particular type of order, so that you're aware of what the NSIDC's limits on those things are. So we'll just quickly take a look at what those required parameters are. Right now, because we haven't yet placed our order, they're fairly straightforward. The rest of them have not even been populated yet. Those will be populated automatically when we go and place our data order. But you also could modify this parameter at this point. It's just a simple dictionary to include any of these parameters, and then those values would stay in during your data order. So now we'll talk a little bit more specifically about subsetting, which, as Amy described really well, is now that we've found what granules might have some data, the subsetting allows us to actually extract the specific pieces of data that we want. And the huge advantage to this is that it allows us to get, well, there are a couple. One is we can download a much smaller data set. And then the other one is that it cuts off the work that we have to do after the fact, because we're not getting larger data we're not getting data outside the region that we're interested in. And so I suspect many of you have worked with geospatial data where you get, your image from whatever resource, and the first step you have to do is actually say, okay, I only want the data for this particular region, and you create your own subset file. So we can do this on a temporal or spatial basis, but we can also do it for variables. This is really helpful if any of you have looked at the variable fields for the ICESat-2 data, which can have somewhere along upwards of 200 variable paths for each data set. And very often we're interested in some subset of those data paths. And so what I'm going to go through here is the process of setting up subsetting parameters for looking at just specific variables. We have an entire another tutorial notebook, which is the 003 on subsetting, that goes over this process in a lot more detail. Unfortunately, we won't have time to present that material during this hack week, but I'm happy to answer questions about it or help people with going into that in more detail. For right now, we're just going to do a little bit of the subsetting to show you what's available and how you would go about setting that up. So just to start with, as I said, under the hood, we're automatically submitting our time and spatial subsetting parameters. You can place an order to the NSIDC that gets the entire granules. And in order to do this, when you submit your order to the order granules function, which we'll showcase later, you simply include subset equals false. So it's really easy to turn this option off. Again, under the hood, we automatically have these temporal and spatial parameters that are being applied. But you might want to know what other options are available, what subsetting and reformatting options are available to you. And so we can run the show custom options, which will go ahead and find all of those options for us. And the dict view equals true here is just an easier way of viewing the variable information. You don't have to use it, but it's a preferred way to view the information for some people, depending on your applications. And so what we can see here is we have these subsetting options. And this is some of the information that Amy talked about earlier. It's looking at what are the options that are available. And so we can see here that we can use spatial subsetting, we can use temporal subsetting because they're both set to true. Data file formats, we can actually have NSIDC give us the data in a different file format other than the native HDF5. Reprojection, reformatting. I'm not going to go into these in great detail. Some of them are not yet available because they're meant to be for some of the future higher level data sets. But I'm going to focus for the rest of our brief time on subsetting here on the variables. So the variables for an ICESat-2 data object are stored in what's called the order vars parameter. And you can interact with this parameter by looking at what variables are available. So this is the available method. And then we can change what we would like to request, which is stored in our wanted parameter using the append and remove methods. And so we're just going to go through that in a little bit of detail. So there are multiple ways for us to get a list of what variables are even available for a given data set. Those are all shown here. We're just going to demonstrate this first one. And we're going to use something called options equals true in there, which instead of giving us a list of all 200 something possible data variables and their individual paths, gives us some separate lists of variables and keywords and beams. So as you saw last week during some of the tutorials, when you looked at what data was available, it's stored as this nested hierarchy of data. And Fernando Paulo is going to teach you a lot more about that in the next tutorial. But it's stored as a set of paths that you can kind of think of as a directory structure. And so you have a variable as the sort of file level. And then you have all of these keywords and beam lists, which are essentially your directories. And so what this function with options equals true is doing is giving you a very specific list of these are all of the variables that are available for this particular data set. So we can see that there's a pretty long list. And then what the keyword and beam list sections does is it tells us some of the different potential paths to get there. And so now I'm going to quickly walk through thinking about specifically modifying that variable list. And I'll kind of go through this, and this information is here as well as in that other subsetting tutorial that I mentioned for thinking about how to modify this list. So if we just go ahead and say, let's just start by adding all of the default variables. And this is not actually set up yet for all of the data sets, so we'd love to have your input. If you're someone who works with this data and has a sort of default list of variables that you always want, we would love to implement that. Right now, it is not implemented for all of the data sets, but it is implemented for ATL06. So if we go ahead and run this cell, first what we're doing is adding those default variables to our list of wanted variables for this data object. And then we have, if we print that list of variables, we get this list here. What this is showing us is here in a dictionary format, we have the variable is the key that is the specific variable name. And then here we have a list. The values for that particular key are all of the paths that have that variable at the end of them. And we can go through and we see all of the possible variables that have been included and all of the paths to get to those variables. So all of these data parameters would be included in our order. And believe it or not, this is not the full list of them, which is part of why we think subsetting is such an important part of being able to order the data, because it can make a really big difference in how big the data set you're downloading is. And if you're not planning to use or don't need all of the parameters that are available, this can be a great way to minimize your download size and storage size. So moving into this example 2, we're just going to clear all of this so that we have a much shorter variable list and can see what's going on. So we can now see if we place this order with subsetting, with variable subsetting, no variables would be returned. So we effectively wouldn't get any data. So we can enter in the append and remove methods of the order variables, which are part of our original parent data object. We can specify specific lists of variables, and this will give us all of the possible variable paths to get there, as well as a few other defaults that are included behind the scenes unless you specifically ask for them not to be included. And so what you can see here is we've specified this variable latitude. And so we've got latitude here as one of our variables, and we've got all of the possible paths that get us to latitude. But what if we're really only interested in looking at the 1L or 2L, or we're only interested in looking at a particular beam? Then we can do things like look at this next example and say we really are interested in beams GT1L and GT3L, but we want latitude and longitude for them. But we don't actually want GT2L, so we're going to remove that. So we're going to do that through 2 different steps. The first one is that append step. And what we're going to do is we're going to append all of the beams that meet all of the variables and variable paths that meet these criteria. So they have a beam list that includes these 2 beams. They're entered as strings in a list. And then the variable longitude. Then we're going to do a remove in order to remove latitude for GT2L. And then we're just going to print it out again so that we can see the difference. And if you look carefully here at latitude, you can see that here we have all 6 of these different beams available. But now, since we've removed GT2L, it is no longer here as a latitude variable that we would get. Similarly, we've added longitude for these 2 particular beams. And there are a lot more detailed examples, again, in that subsetting notebook. But what we're going to do so that we can move forward is we're going to go ahead and clear these variables that we put in there. We're going to set it up to just use the defaults and then print those out again. And so that's what you can see here is we now just have this default list of variables. And then we just need to take one more step, which is to make sure that we actually tell our data object that we now have this list of variables available in order to include them in our order. And so this can be done in a couple of ways. They're described here in this text. I believe they're shown in much more detail in that other notebook. But what we're going to do right now is we're going to just very simply add them as a keyword argument to this subset parameters, which, if you remember, when we looked at it before, it only had the time and spatial parameters. And we've now added this coverage parameter, which is the particular variables that we want. And what you can see is this, it turns it into a formatted string of this really long list of all of the variable paths and variables that were nicely formatted for our readability here. So with that, I'm going to turn it back over to Amy to go over data ordering.
Okay, great. Thanks, Jessica. So this next step, we really only have two sort of commands to run here, but I'm going to walk through a couple of other sort of examples that are, obviously commented out right now, but they may be of interest to you. So we're now actually at the point, we've gathered all our, time, area of interest, the variables that we've extracted that we're interested in, as Jessica explained. So now we're actually going to finally place that order. Again, as Jessica mentioned, this is sort of allowing us to sort of queue, basically sending this sort of asynchronously as a sort of data order, gives our system at NSIDC sort of the chance to queue orders. And, like Jessica was saying, you don't have to kind of rely on a continuous connection if you want to do this synchronously. So all you really need to do is, with your data object, it's region A.order granules. And what basically this is going to do, if you haven't already ran the subset params method that Jessica described, where we're setting our wanted coverages, if you don't do that, this will basically place a very simple order without variable subsetting. But because we already ran that, because we've already sort of given the object our wanted variables, and now we just simply execute this region A.order granules command, that already has all the information that we've already sort of sent and set up, and allows you to actually do the ordering. So at its sort of simplest, this is giving you kind of some basic information about your order that you are now placing through the NSIDC API. So it's first telling you you have 5 granules, like we showed earlier. Those were the 5 that were returned through the metadata. The order submitting to NSIDC, it's going to give you sort of some processing information, or a status, essentially. So the first status that we pinged NSIDC is saying it's already processing. It may take a few moments. Obviously we're all hitting this at the same time, but it's a small order, so it should complete for you pretty quickly. And then it's giving us this sort of message back. We'll talk about this, in a little more detail. But it's basically saying, out of the 5 granules that you sort of asked us to subset, 2 out of those 5 did not contain data in that area of interest. So it's sort of going to give you this complete with errors message back. And again, I think Jessica's going to go into that in a little more detail. The other things you can do, again, these next 2 code blocks are just commented out right now. But what this is going to do, if you did, enter your email address earlier when you set up your Earth Data login, credentials, by default, you are going to get an email response. You should first get sort of an initial, sort of whether it's pending or processing, sort of an order status email, and then you'll get another email that actually, gives you the order information. You can have access to, to the files that were delivered. You can set this to false though. So, the fact that we have by default set these orders up to kind of do sort of these 10 granule chunks, if you will. If you're doing a lot of orders, you may be getting quite a lot of emails. So it's nice to have that if you want that sort of email sort of history, but you can set that to false. So that's commented out, but you are, feel free to do that. And then the other code block right below that, that's also set, it's commented out right now, is you can also set a verbose equals true on your order. And this will provide a lot more information. So if you did this now, feel free, if you want to, experiment with this, you could uncomment it and run the cell. It's going to give you a lot more information about the order status. And it also gives you the API sort of URL itself. So if you actually want to see what's being sent behind the scenes, that might be a nice way, just if you're interested in learning a little bit more about sort of what's happening on the back end. Like you could basically take that entire URL and customize it and and sort of modify it yourself. So again, just some more information there that this does allow you to do. And then finally, we actually will run this. This gives you, so this granules.order IDs provides the order ID back. So if you were to kind of rerun this with the same data object that you have, your region A, let's say you wanted to maybe modify it or just rerun it for some reason, this sort of list will get appended with each order ID. So it's a nice way when you're kind of within the icepyx framework to keep track of all the orders that exist. You'll kind of see how you can work with those and come back to that information in the next step to actually download. So again, all we've done here is sort of place that order. And now we're going to move into actually finally, extracting and downloading the data, in this case to our hub environment. So I will hand it back over to Jessica for that.
Cool, thank you, Amy. So as Amy said, we're now going to move specifically into downloading the order. So we've placed this order, but it's still just sitting at the NSIDC. We need to actually go ahead and download it. In order to do that, we have to specify where we want it. In this case, we are specifying that path to just be a download directory right within this repository. But you can enter anything you want as a path here. You can enter a directory that exists or does not exist. The system will check to see if that directory exists, and if it does not, it will create it, which is really handy if you're like, oh, I'm downloading data for a new place and want it to just be in this particular folder. And then we're just going to go ahead and run that region A download granules and enter that path, which is a required input so that the system knows where to put it. And this is also another place where we can, as I'll show in a few minutes, can make our lives simpler. We don't actually have to independently place the order and download the granules. If we skip right to this download step, it will under the hood call the granules step, which means that we can feed in this coverage keyword of the variables that we want into the download granules function in order to subset by variable without having to individually call all of these steps. So I'm just going to go ahead and run this. And similar to before, we'll get a little bit of information. Because it's such a small order, it completes really quickly. And if we were to now look over here in our navigation panel, we can see I now have this new download folder that was just created. If I go in there, I can see all of my processed data sets. And if you use the NSIDC subsetter, it will prepend the processed word here to the beginning of the file name, which is a great clue that it is not the entire granule that you have here. And as you can see, there are only 3 files that were downloaded. And the reasoning for this is what Amy described earlier. We saw this no matching data. And if you think back to that map image that we saw before, we can imagine that, you know, maybe this granule here doesn't really, once like the subsetter gets into the details, it doesn't really actually have any data that's within this region. It's just got a bounding box that makes it look like it could be right on the border here. And so that's what's happening here. This no matching data error is going to show up for those granules that don't have data, but that doesn't mean that you don't have data that's been ordered. And this is something that is very confusing, and something that NSIDC is working on, how to make some of these messages a little bit clearer. And for those of us who haven't been staring at them all day. But so if you get these error messages, try downloading your data and see if there is actually any data, because it can be confusing and kind of make you think, oh no, there's nothing there. But in fact, we do have 3 granules of good data once we go ahead and download those. Some of you may also have noticed that when the data itself was downloaded, it was downloaded into this directory, it was unzipped, and it was moved into this particular directory. So behind the scenes, what's happening, the data is being downloaded as a zipped folder, or zipped files within a specific folder. And we're making it much easier for you to now access that data later by having it already unzipped and available. And we're in the process of making that something that is optional, so that if you're ordering and downloading a much larger data set, you don't necessarily have to unzip those files, but it will still put them all in this one parent directory rather than leaving them sort of down a rabbit hole of directories. Another handy feature is that if your download is interrupted, you can restart it, which this is obviously very helpful if you know, your internet goes out or you have a really large download and something doesn't work. You don't have to totally start from scratch with replacing your order. And this is what Amy was saying. This behind the scenes, again, is using these order IDs that have been stored in order to allow this functionality to work. And so I'm just about out of time, but what I've put here at the end is what we can call the quick start guide. And this is, as I said at the beginning, we just went through this, you know, really long tutorial with all of these great options. But at the end of the day, you can boil it all down to these really simple commands if you have a good idea of what you want, or aren't trying to do a ton of subsetting. And we can boil it all down to these 3 commands, which define our data object with those initial parameters in terms of what data set we want and our spatial and temporal ranges. We have to log into the Earth data so that we can get access to the data, and then we can go ahead and download the data. And I think for me, the sort of only, like the most important step to sort of add in here that's not strictly required would be to think about those subsetting options and creating variables for subsetting.